NASA just revealed massive water ice deposits in the moon's shadowed craters, regions untouched by sunlight for billions of years. These frozen voids could power humanity's first lunar city, but building there means facing extreme cold, radiation, and cosmic threats. One wrong step, and it's over. For nearly 6 decades, the moon stood as a silent testament to human courage and curiosity. In 1969, a handful of brave astronauts walked its barren surface, marking one of humanity's greatest achievements. But after that fleeting moment, the moon grew quiet again. A distant monument to exploration rather than a place to call home. Today, NASA's Artemis program is transforming that history. This mission signals a profound shift from short visits to long-term presence. Artemis is not about reaching the moon only to plant a flag and return. It's about staying, building a sustainable outpost where humans can live and thrive off-world. You might wonder, why now? Why hurry to the moon centuries after we first set foot there? The answer lies in Earth itself. Our challenges here are mounting. Climate change, dwindling natural resources, and population pressures make clear that humanity can't rely on just one planet forever. The moon offers a new frontier for innovation and survival. More than a science mission, Artemis is a leap toward a larger destiny. It aims to establish a permanent base, a hub for scientific discovery, technological advancement, and preparation for even more ambitious journeys to Mars and beyond. Picture this: a lunar laboratory where experiments run uninterrupted, providing precious insights about space and planetary science. A refueling station for spacecraft embarking on deep space missions. More than that, a home where astronauts don't just survive but live with purpose and hope. Creating this base requires not only cutting-edge technology but also international collaboration and a pioneering spirit that embraces risk and uncertainty. Every structure built, every system tested, contributes to the blueprint for living beyond Earth. But perhaps the most transformative aspect of Artemis is how it challenges our perspective. Space is no longer an unreachable frontier viewed from a distance. It's the next chapter in human existence, an expansion of our civilization into the cosmos. Because ensuring humanity's long-term survival means learning to live beyond the cradle that formed us. This mission is a call to imagine ourselves as not just dwellers of Earth, but as citizens of the solar system. This bold vision is grounded in the reality of science and the urgency of our times. Artemis marks the beginning of a future where humanity is truly multiplanetary, where the moon is not just a stepping stone, but a second home. And that future, with all its challenges and promises, begins now. The moon's south pole is unlike any place humans have ever settled. It is a land of extremes, a harsh and alien environment where light and shadow dance in ways unimaginable on Earth. This region is defined by its deep craters, some of which have never seen sunlight in billions of years. Within these eternal shadows lies a precious secret: water ice, preserved in the coldest corners of the solar system. For NASA, this makes the South Pole a logical yet daunting choice. Water is the lifeblood of any settlement, not just for drinking, but for generating oxygen and even rocket fuel. Access to these resources could transform the moon from a barren rock into a living outpost. But the terrain is unforgiving. The surface is a rugged wilderness of steep cliffs, deep shadows, and fine, abrasive dust that clings relentlessly to everything it touches. Temperatures swing from blistering cold in the shadows to intense heat under the sun, creating extreme challenges for any explorer or machine. Survival here means mastering these conditions, finding light where there is darkness, warmth where there is cold, and stability where the ground shifts underfoot. NASA's choice reflects a blend of necessity and ambition. The South Pole offers unparalleled scientific potential, but also demands innovation to overcome its brutal environment. Before anyone can call this place home, the harsh reality of building there must be faced. Every step, every structure, every plan must confront the unknowns of this alien landscape. What looks like a frozen abyss is actually the gateway to humanity's future off Earth. But turning that promise into reality requires solving problems no one has ever faced at this scale. The Moon's South Pole is a land of promise and peril, a place where hope and danger are inextricably linked. And before humans can live there, we have to build. Building a base on the Moon might sound like science fiction, but the challenges start at the ground level, literally. The lunar surface, covered in a fine powder called regolith, is one of the biggest obstacles NASA must overcome. This dust is unlike anything on Earth. It's sharp, abrasive, and clings to everything indiscriminately. Astronauts from Apollo missions reported it stuck to their suits and equipment, causing wear and tear that no one fully anticipated. Regolith is also electrically charged, making it cling stubbornly to surfaces and even float in the low lunar gravity environment. This creates a persistent hazard, not just a nuisance. Early solutions focus on simple, temporary fixes. NASA engineers experiment with soil binders, materials that can harden the loose dust into solid pathways for rovers and astronauts to cross safely. But this is only a start. For a permanent settlement, these makeshift roads won't be enough. Long-term plans involve turning the very soil of the Moon into building blocks. Using techniques such as microwave heating, scientists can melt regolith into glass-like material, creating strong and durable slabs, something like lunar concrete. Every test reveals complex new problems, from how cracks form in low gravity to how materials react under extreme temperature swings. Progress is slow, and setbacks are common. But from this struggle comes incredible ingenuity. Because if taming the dust proves this difficult, building roads, habitats, and infrastructure will require equally radical innovations. The Moon's surface is a harsh, unpredictable frontier, and the first step to domesticate it is also the foundation for everything else to come. What if the dust gets everywhere? What if the ground itself resists our efforts? These questions linger as NASA pushes forward, innovating with each experiment. Turning regolith from an enemy into an asset is the key to building sustainable homes on the Moon. And conquering this challenge will set the stage for humanity's first real homes off Earth. Exploring the Moon's South Pole isn't like driving a car on Earth. It's a challenge that redefines movement itself. To journey across this alien landscape, astronauts will rely on specialized pressurized rovers, essentially moon-sized RVS designed to support life in the most unforgiving conditions. Inside these rovers, crew members can live and work for days or even weeks, shielded from the harsh vacuum and extreme temperatures outside. The terrain is treacherous, jagged rocks, deep shadows, and dust that punishes every surface. Moving here is slow and deliberate. Beyond the physical obstacles, the psychological toll of isolation and confinement weighs heavily on the crew. Inside their mobile habitats, they confront a profound loneliness, surrounded by vast silence and emptiness. But movement is essential. Rovers enable astronauts to collect critical samples, test technologies, and scout future construction sites. This mobility extends their reach beyond the base, turning immobility into exploration. Yet, even the best rover isn't a substitute for a real home. It offers shelter temporarily, but humans need more, a place to rest, to dream, to thrive. The question looms: where will these pioneers build their lasting refuge? And how will we design it to withstand the moon's relentless challenges? Navigating the lunar South Pole requires new engineering and a new mindset, a constant battle against the environment wrapped in the fragile bubble of human life. This is movement like never before, demanding bravery, both physical and mental. As NASA advances rover technology and mission planning, understanding how humans will get around is key to unlocking the next step: permanent habitation on the moon. Once mobility challenges are addressed, NASA's immediate goal is to provide astronauts with their first real shelter on the moon. The solution? Foundation habitats. Compact, inflatable modules designed to offer safe, livable space in an environment hostile to human life. These habitats are ingeniously engineered. They will be lightweight for transport, then expanded on the lunar surface into protective shelters. Covered with layers of lunar soil or regolith, these modules shield occupants from deadly cosmic radiation and the moon's extreme temperature swings. Inside, they'll house small crews, typically 4 astronauts, providing air, warmth, and essential supplies. The design balances utility and comfort, blending hard science with the psychological need for personal space and security. Living off Earth means astronauts won't simply work. They'll live there, facing isolation and new realities. These habitats mark the crucial transition from temporary missions to sustained presence. They are the first hearths of humanity beyond the cradle of Earth. Yet, while these inflatable homes represent a huge leap forward, they are not permanent solutions. Their materials wear under lunar conditions, and their protection is limited over time. This limitation keeps the vision moving forward towards more durable, long-lasting bases. The foundation habitats are a stepping stone, a symbol of human adaptability and resilience as we prepare to build the moon's first true city. The foundation habitats are just the beginning. To truly settle the moon, NASA and its partners must design homes that last, structures built from the moon itself. This means transforming the very soil beneath our feet, the regolith, into building materials. Scientists have developed techniques to 3D print lunar bricks by compressing and heating regolith. Imagine autonomous robots shaping these bricks into walls and domes, working tirelessly to create infrastructure before humans even arrive. China and ESA are exploring similar robotic construction methods, each aiming to build habitats strong enough to withstand radiation, micrometeoroid impacts, and the brutal temperature swings of lunar nights. Some designs envision glass domes that glitter under the stars, enclosing thriving habitats filled with life. Others propose underground spheres carved beneath the surface, where conditions are stable and protected from cosmic dangers. These advanced materials and technologies represent a tremendous leap from inflatables. They not only shelter human life, but also inspire hope, a tangible sign that humanity is no longer just visitors on the moon, but residents. Robotic builders are key to this future. They will operate autonomously, assembling homes and infrastructure piece by piece as astronauts focus on exploration and research. This partnership between humans and machines is the blueprint of off-world living. Yet, even with perfect construction, these cities will need power, an engine to sustain life and growth. And powering the moon base raises perhaps the greatest challenge of all. This stage marks a turning point. The vision of a vibrant lunar city is within reach, but success depends on solving complex engineering puzzles and pushing the boundaries of imagination. The moon's first true city will be a monument to human innovation and perseverance, standing as a beacon of what's possible beyond Earth. Energy is the lifeblood of any city, and on the moon, power is the make-or-break factor for survival. Solar energy seems an obvious choice, but the moon's days last about 14 Earth days followed by 14 days of night. creating long periods of darkness that sunlight alone cannot bridge. To solve this, NASA is turning to small, scalable nuclear fission reactors. These compact power systems, being developed in partnership with companies like Rolls-Royce, promise continuous, reliable energy regardless of the lunar day-night cycle. These reactors will likely be placed in permanently shadowed craters, safely out of reach but close enough to supply heat and electricity to the base. This strategic placement minimizes risks and stabilizes energy supply during the long, freezing lunar nights. Having steady power means life support systems can run without interruption. Oxygen generation, water recycling, heating, all the essentials. But nuclear power brings its own challenges: safety, maintenance, and the unknowns of operating in such a remote environment. What happens if the system fails? Can astronauts repair it alone? These risks underscore the fragile balance of life on the Moon. Reliable power doesn't just keep lights on, it fuels humanity's foothold beyond Earth. It's the engine that will drive exploration, sustain habitats, and unlock the Moon's potential as a gateway to the stars. Mastering energy on the Moon is as critical as building the habitats themselves. It may very well decide the fate of humanity's first city off-world. Building a city on the Moon is not just about technology or survival, it's about the future of humanity. The lunar base will serve as a launch pad for deeper space missions, from crewed journeys to Mars to exploration of distant moons like Titan. It's a proving ground where we learn how to live beyond Earth, developing the skills and technologies that will keep us alive on worlds without atmosphere or water. Most importantly, this effort ensures our species can survive catastrophic events on Earth. The Moon City becomes our lifeboat, a second home to safeguard the continuity of human civilization. This moment marks a new chapter, where humanity embraces its destiny as a multiplanetary species, reaching beyond our blue planet, stepping into the vastness of space with purpose, pride, and hope. We're not just building a base on the Moon, we're planting the first seed of human civilization off Earth. Imagine a future where humanity thrives beyond our planet, expanding into the cosmos. Join the journey, stay curious, and support the exploration that will shape our destiny. The Moon is just the beginning. Our second home awaits.